Hello everyone. Today I want to talk about something that sits in the overlap between nutritional science and practical eating, a dimension of how food works in the body that most people never consider, and that the research is increasingly showing has consequences that are both significant and largely independent of what you are actually eating. Food combinations. Not in the sense of the outdated food combining theories from the 80s, the ones that claimed protein and carbohydrates should never be eaten together, or that fruit must always be consumed on an empty stomach. That framework was not well supported by the science, and I am not here to revive it. What I want to talk about is something more grounded, more specific, and more actionable: the ways in which the pairing, sequencing, and co-consumption of specific foods meaningfully alters nutrient absorption, glycemic response, gut microbiome activity, and hormonal signaling in ways that can change the metabolic outcome of a meal without changing a single ingredient in it. Let me start with the combination that the research has been most consistently clear about in recent years. Carbohydrates paired with fat, fiber, and protein versus carbohydrates consumed alone. A piece of white bread consumed on an empty stomach with nothing else delivers glucose to the small intestine rapidly, producing a steep blood sugar rise and a corresponding insulin surge. The same piece of white bread consumed alongside olive oil, vegetables, and a protein source produces a measurably different glucose response: flatter, more gradual, with a smaller insulin requirement and a longer period of satiety. The bread did not change. What changed was the digestive context it arrived in. The second combination principle is sequencing, which I have touched on in a previous video but which deserves specific attention here in the context of food pairing more broadly. The order in which food components are eaten within a meal produces measurably different digestive and metabolic outcomes even when the total composition of the meal is identical. Eating vegetables and protein before carbohydrates consistently produces a flatter post-meal glucose response than eating carbohydrates first, with the difference in glucose peak sometimes exceeding 30%. But the sequencing effect extends beyond glucose. According to research, eating protein at the beginning of a meal significantly increases the release of cholecystokin and peptide YY, both satiety hormones, compared to eating protein at the end. Starting with fiber increases the thickness of the intestinal mucus layer that moderates nutrient absorption throughout the remainder of the meal. Starting with carbohydrates, by contrast, produces the most rapid glucose entry, the largest insulin release, and the fastest return of hunger, even when the total caloric and macronutrient content of the meal is equivalent to one begun with fiber and protein. The third combination principle involves anti-nutrients and the foods that counteract them, a pairing dynamic that most people never think about. And that has genuine implications for mineral absorption and gut health. Many nutritious foods contain antinonutrients compounds that bind to minerals or inhibit digestive enzymes, reducing the absorption of nutrients they are co-consumed with. Phytic acid in legumes, grains, and seeds binds to iron, zinc, calcium, and magnesium, forming insoluble phytate salts that pass through the gut unabsorbed. Tannins in tea, coffee, and some vegetables inhibit iron absorption when consumed alongside iron-containing foods. Oxalates in spinach and other dark leafy greens bind to calcium and reduce its bioavailability significantly. Understanding which food combinations reduce antinutrient impact is one of the most practically useful pieces of nutritional knowledge available, and it is almost entirely absent from popular dietary conversations. Vitamin C dramatically enhances non-heme iron absorption by reducing Fi cubed to the more absorbable Fi squared form, and by chelating iron in a way that prevents phytate binding. According to research, consuming a vitamin C-rich food alongside an iron-rich plant food increases iron absorption by 2 to 4 times compared to consuming the iron source alone. A handful of bell pepper alongside lentils, lemon juice squeezed over a spinach salad, strawberries with fortified oatmeal. These are not exotic combinations. They are the kind of pairings that traditional food cultures developed before anyone understood the biochemistry, because they worked. The fourth combination principle is the fat-soluble vitamin pairing, and this one affects a nutrient category that most people assume is absorbed automatically from the foods that contain it. Vitamins A, D, E, and K are fat-soluble. They require dietary fat present in the same meal to be absorbed efficiently. Consuming a salad rich in beta-carotene, the precursor to vitamin A, with a fat-free dressing produces dramatically lower beta-carotene absorption than the same salad with an oil-based dressing. Consuming vitamin D-rich foods without accompanying fat reduces vitamin D absorption substantially. And yet fat-free preparation of vegetables is still widely recommended in contexts where it directly undermines the nutritional value of the food being consumed. According to research, The addition of even small amounts of fat, as little as 3 to 5 grams to a meal containing fat-soluble nutrients significantly increases their absorption. In one study, beta-carotene absorption from a mixed salad was approximately 4 times higher when consumed with a full-fat dressing compared to a fat-free equivalent. The vegetable content was identical. The presence or absence of fat at the meal determined whether the fat-soluble nutrients in those vegetables were actually delivered to the body. The fifth combination principle is the fermented food and prebiotic pairing, and this is where food combining enters gut health most directly. Fermented foods, kefir, kimchi, miso yogurt, sauerkraut, contain live bacterial cultures that can transiently influence the gut microbiome environment. Prebiotic foods, garlic, onion, leek, asparagus, oats, bananas, contain fermentable fibers that feed gut bacteria. Consumed together, the live bacterial cultures from the fermented food have immediate access to the fermentable substrate from the prebiotic food, creating a symbiotic effect in which the introduced bacteria have the fuel they need to produce beneficial metabolites and compete effectively within the gut environment. I hope this gave you a genuinely useful lens on something you do multiple times every day. Drop a comment and tell me which combination you are going to apply first. I read all of them. If this was useful, hit the like button and share it with someone who is eating all the right foods but not necessarily in the right combinations. And if you are new to Nutriflow, subscribe and hit the bell. See you in the next one.